Hello everyone, I am Awad Rahman Ahmed, MLflow Ambassador, and I welcome you to the April edition of This Month in MLflow. This is a monthly moment where I just try to reflect on what's happening in the MLflow ecosystem, what's new, what's meaningful, and sometimes what we can learn from how it's all evolving. Now I sometimes get asked, what does an MLflow Ambassador actually do? And aside from the formal definition you will find on the official MLflow Ambassador program page, you can think of me as someone who helps highlight the hard work that has been done by the many excellent contributors behind this project. I am really just someone who is driven by curiosity, following what's new in MLflow anyway, and this series is simply the extra step where I share what I'm learning so you can stay up to date too. That being said, for this month, I would like to begin with something that's worth pausing for, and that is MLflow has just passed 20,000 stars on GitHub. Now, stars are not everything, but they do mean something, and they are a simple way for people expressing how this tool helped them and they see value. And in open source, that kind of signal matters. It's not just about popularity, but it's about consistency, trust, and staying power. What I find even more interesting is that the shape of the growth itself. If you look at MLflow stars history, you will notice something unusual, and it follows a remarkably linear pattern. MLflow has been gaining about 3,000 stars a year consistently since it launched. No viral spike, no sudden hype wave, just a steady year-over-year adoption. And to me, that kind of trajectory says a lot. It reflects ongoing usefulness, not just excitement. MLflow has continued to deliver value, and people have kept showing up. Now, if you look at some of the key moments behind that curve, it all started in 2018 when MLflow was first announced at the Spark Plus AI Summit, which is now called the Data Plus AI Summit. If you haven't seen that launch talk by Matej Zaharia, I really think it's worth watching. It's one of those underrated talks in machine learning, just a very clear explanation of the real problem and a thoughtful design behind the solution. It's still holds a lot of value today, especially if you are interested in how to introduce a new tool in a way it feels honest, grounded, and practical. Then the milestones came in steadily. In 2019, MLflow reached 1 million total downloads. By 2023, it had crossed 100 million total downloads. And by 2024, that number had doubled again, over 200 million. So while downloads show us the breadth of adoption, the GitHub stars show something else, and that reflecting this appreciation. Yes, 20,000 stars is a nice milestone, but more than that, it is a reminder that this project continues to resonate with people and that its relevance and value have held strong over time. Alright, let's talk about MLflow 2.22.0, which was the only release in April. Now, to be honest, this one isn't packed with big announcements or headline features. It's more of a maintenance style release, and that makes sense, especially with MLflow 3 currently in preview, which may be where a lot of focus is going. But if you're working on real generative AI projects, doing model tuning or running MLflow in production, you will find a number of practical updates here that really help. To keep things simple, I will group the features based on what they improve, a set of updates around LLM observability and tracing, a couple focused on infrastructure and cloud setup, and a few that improve the developer experience. I will walk you through the 4 features I think are the most meaningful, and I will leave the rest for you to explore at your own pace. Let's start with the group of updates that are especially relevant if you are working on chatbots or any kind of LLM-powered workflow. Over the last few releases, MLflow has been putting a lot of emphasis on tracing and observability. In simple terms, it's about being able to track what actually happens during an LLM interaction, not just the final output. So what prompt went in, what are the intermediate steps, what did the model respond with, and tracing captures all of that in a structured way, which is useful when you are debugging, monitoring, or trying to understand the model behavior. Now, if you are not familiar with MLflow tracing, that is totally okay, as MLflow supports supports a wide range of users, data scientists, platform engineers, ML researchers, and not every feature is meant for everyone. But if you are curious, there is a great walkthrough in the MLflow YouTube channel about MLflow Tracing, and I have added the link below if you want to check it out. So the first feature that we can highlight from this release is support for the new OpenAI Responses API. Now maybe you are wondering, what is this new Responses API? What was the old one at the first place? Why does MLflow care, and why should I care that MLflow cares? So here is a quick rundown. Until recently, OpenAI's main API for LLMs was the chat completion API. You would send a list of messages and get one clean reply back. That's what most of us have been using. Now, OpenAI is rolling out a new option called the Responses API. It's designed for more complex use cases, things like agents, tool calls, multi-step logic, and richer metadata. Think of it like chat completions, but with extra everything. The Responses API gives you not just the model reply, but tool output, reasoning, intermediate results, and all packed into one response. Now, MLflow already supported tracing for the older chat API, but this new Responses API is more detailed and its structure doesn't perfectly match MLflow's current tracing schema. So why does this matter? Well, if you are starting to use the new Responses API and a lot of new OpenAI features are built on it, you will still get logs, you'll still be able to monitor and debug. Our next feature is about Gemini support in the MLflow AI Gateway. And if you are wondering what is AI Gateway, this is a great time to explain it. And the MLflow AI Gateway was introduced back in MLflow 2.5 around the midst of 2023. It provides a standardized interface to interact with different LLM providers like OpenAI, Anthropic, or Cohere, all through a single unified endpoint. So instead of writing separate integration code for every provider, managing credentials, rate limits, and different request formats, you configure them once in the gateway and just call one clean API. It is especially helpful when you want to compare providers without changing your code, or you are working across cloud environments with different LLM services. And kind of a quick fun fact that you can discover when you browse the releases, that at one point this AI gateway was actually renamed to deployment server and even marked for deprecation. But in MLflow 2.17, that decision was reversed and it's now officially back to being called the AI gateway with continued support and updates. Now on to the actual feature. With MLflow 2.22, Gemini embedding models are now supported inside the AI gateway. That means you can use Gemini to generate embeddings alongside OpenAI or Cohere for workflows like semantic search or your retrieval augmented generation, the RAG system. And because of how the gateway works, you don't need to change your core logic. You just update your configuration and you are good to go. Now, if you have already been using Gemini models, you might know that this is not the first time MLflow has supported them. Back in MLflow 2.18, Gemini was added to tracing. So if you were logging and observing interactions with Gemini, that already worked. But this new release brings Gemini to the model calling side too. Just a quick heads up, as of today, the MLflow AI Gateway does not support Windows. So if you are developing locally on Windows machine, you might hit setup issues. But if you are working in cloud or on a Linux-based environment, there's no problem. The next feature is the new asynchronous trace export feature, and which might sound deeply technical at first, but it's actually about something very practical. It's performance. And in MLflow 2.22.0, when you log traces, for example, for an LLM-powered app, MLflow now supports doing that asynchronously, meaning trace logging no longer has to block your application. It can now happening in the background. That's especially useful in production environments where you want to keep your app faster and responsive even while it's logging lots of events behind the scenes. Now, there is a catch though, that this new asynchronous behavior specifically applies when you are exporting traces to Databricks trace server. So if you are just using MLflow locally or with a different backend, it's not entirely clear whether this asynchronous behavior applies to your setup right now, at least based on what has been released. I actually also checked the agent observability documentation in Databricks, and interestingly it was updated on April 21st, just before the MLflow release, and it doesn't mention this change yet. Even the pull request says that further documentation will be added later under the production tracing section in the MLflow docs. So who should care? If you are using Databricks for MLflow tracing, this is a great news. Asynchronous logging is now the default, and your app might feel faster without you needing to change anything. The next feature we want to discuss is related to the infrastructure and cloud support. Specifically, if you are working in an Azure environment, this one might be for you, and that is there is a support for using Azure Data Lake Storage or ADLS as an artifact store. And to give you some context is that in MLflow tracking, the artifact store is where MLflow saves the larger output, things like model weights, like the pickled scikit-learn model, or visualizations and PNG plots, or even CSV files and data files. These are considered artifacts, and they are separated from the core run metadata like metrics, parameters, and tags, which get stored in the backend store, usually in a relational database. Up until now, MLflow supported a number of artifact storage like Amazon S3, like Azure Blob Storage, Google Cloud Storage, but Azure Data Lake Storage, despite being widely used in the Azure ecosystem, wasn't officially supported. And with this MLflow 2.22, the change is that you can now configure MLflow to store artifacts in ADLS with support for two standard authentication methods. So you can use environment variables to authenticate via shared access signature, that is a SaaS, or using the default Azure credential which support login via Azure CLI or service principals. Of course, this gives you the flexibility as well as the security and removes the need for these awkward workarounds. It's specifically useful if your team is already using ADLS in production or you want some kind of centralized artifact storage across teams. Alright, so that is why I will wrap it up for this month's walkthrough. Now, there are a couple of other features in this release that I did not go into, like the Optune storage utility for parallel hyperparameter tuning, and there's another one for the auto-refreshing text artifact viewer in the user interface. If those are relevant to your workflow, I definitely encourage you to check them out. You will find all the details in the release page. And thank you very much, of course, for joining me, and talk to you next month.